Today we are going to be looking at number bases. Then at the end of this tutorial, you should be able to explain a number base. We also look at how to convert base 10 number to any given base and vice versa. We also perform some computations on number bases using the basic mathematical operations, the addition, subtraction, multiplication, and even division. And then we also solve number bases that involve equations. So what then is a number base? A number base is simply a system of counting and representing figures using the combination of digits. So in our everyday life, we represent figures and count objects using the base 10 system. We use 10 digits to represent any figure. When we count money, when we measure distances, etc., when we count objects, we use the base 10 system. So it is a way of counting in bundles of 10. Every day, when we count objects, money, measure distances and quantities, we write them in base 10. So it's the common base that we know, like 25 boys. This 25 is written in base 10. So the base of a number is written as a subscript. So this is base 10, so I write it. But because the decimal system or the base 10 system is the common system that we represent figures and quantities with, we mostly don't write the base, that's the base 10. So when you write any figure like 13, it means it's in base 10 without the base as a subscript. But for any other bases, we have to indicate the base of the number. So for instance, if this 13 is in base, let's say base 4, we have to indicate the base there. So the first one that we can talk of is the base 2, which we call the binary system. And it uses only zeros and ones. And this system is what the programmers use to code. So it uses zeros and ones. So the computer uses the binary system. Then we have the base 3. The base 3 is for ternary system, called the ternary system. And it uses 0, 1, and 2. So you see that the digit is 1 less than the base. Then we have the base 4 system, which we call the quaternary system. And then it also uses from 0 to 3. But for the purpose of this class, we'll limit ourselves up to base 10. So now let's get down to serious business. Let's convert base 10 numbers to other bases. So the first number, we are going to convert it to base 2, this 21. So in converting a base 10 number to any given base, we will repeatedly divide the base 10 number by the base that we are converting into. So for the first example, we are converting from base 10 to base 2. So I will divide 21 by 2. 21 divided by 2 is 10, remainder 1. Then 2 into 10 is 5, remainder 0. 2 into 5 is 2, remainder 1. Then 2 into 2 is 1, remainder 0. 2 into 1 is 0, remainder 1. So the remainders here, they are the base 2 number for 21. We write it from the last remainder to the first remainder that we got. So we write it from bottom up. So 21 base 10 is equal to 10101 base 2. Let's look at the second example. So we are also converting 31 to base 3. So 31 base 3. I will repeatedly divide the 31 by. So I'll divide 31 by 3. So 3 into 31 is 10, remainder 1. 3 into 10 is 3, remainder 1. And then 3 into 3 is 1, remainder 0. And then 3 into 1 is 0, remainder 1. So just like the first one, that one we write it from bottom up. So 31 base 10 is equal to 1011 base 3. So we divide it by 5. Then 5 into 213 to go into it 42 times, remainder 3. Then 5 into 42 will be 8 times, remainder 2. Then 5 into 8 is 1, remainder 3. Then 5 into 1 is 0, remainder 1. So we write it from bottom up. So 213 base 10 is equal to 1323 base 5. Then the last one also in base 8. So 8 into 724 will be going to it 90 times, remainder 4. Then 8 into 90 is 11 times, remainder 2. Then 8 into 11 is 1, remainder 3. Then 8 into 1 is 0, remainder 1. So this one too will get this 10 will be equal to 1324 base 8. Now you get it. Now let's look at how to convert a base 10 number with decimals to other bases. Let's convert 24.25. So let's convert it to base 2. So 24, I'll continuously divide it by 2. I'll get 12, remainder 0. 2 into 12 is 6, remainder 0. 2 into 6 is 3, remainder 0. And then 2 into 3 is 1, remainder 1. Then 2 into 1 is 0, remainder 1. Okay, so this becomes the whole number part, which is what? 11000. Alright, point this one. So now it's left with 0.25. So to convert the decimal part, the 0.25, now we'll do the opposite of what we did here to get these remainders. We're dividing the whole number part by 2 and keeping the remainders, and when we finish we wrote the answer from bottom up. So with the decimal part, what we do is that instead of dividing, we'll multiply. So we'll multiply this by the base 2. Okay, then we'll keep the whole number part. So this is what I mean. So 0.25, then we'll multiply by 2, and this will give us 0.5. So this one I'll keep the whole number part. So the whole number is 0. So I'll take the 0 part. Then it will leave with what? 0.5. So I'll take the 0.5 again and multiply by 2. Then I'll get 1.0. That will give you 1.0. Then also I'll keep the whole number part, which is what? 1. Then it will leave with what? 0. So 0.0 times 2 is equal to 0. Okay, so that's it. Then instead of writing from bottom up, this time we write it from the top down. Okay, so it will be point, then 0, 1, these two. I hope it's not confusing. We are doing the opposite of what we did to the whole number part. We divide it, keep the remainder, you keep dividing it, and be writing the remainder. The decimal part, you multiply it by the base. You multiply the decimal part by the base. Okay, then you keep the whole number part. You keep multiplying, keep the whole number part, you multiply, keep the whole number part. And when you finish, you write it from the first whole number part that you start keeping to the last one. Unlike the whole number part where you write it from bottom up. The decimal part, you write it from the top to the bottom. Let's try another example. So let's take 52.1, okay, 17. Okay, we are converting this one to base 6. So we are converting to base 6. Okay. So the whole number part, so 52 divided by 6. So going to it 8 times, remainder 4. Then 6 into 8, 1 times, remainder 2. 6 into 1 is 0, remainder 1. So the whole number part will give us, I want to write it from the bottom up, don't forget. So 1, 2, 4 points. Now the whole number part is what? 0.17. We multiply by the base, which is 6. Will be equal to, I think it's 1.02. They will keep the whole number part, which is 1. Then we left with what? 0.02. Also multiply by 6. They will get 0.12. So the whole number part 2 is 0. This one. Then we have 0.12 multiplying 6, and that will give us 0.72. Then the whole number part is 0. Then again, if you multiply 0.72 times 6, we'll get 4.32. The whole number part is 4. Then take it again, 0.32 by 6, 1.92. Then the whole number part is 1, and then it goes on and on. So get, when I find it and you get like 3 decimal places, you can just end it there. So this one we are writing from the top to the bottom. So it will be 0, sorry, it will be 10041 base 6. So now let's convert from other bases to base 10. Let's convert this to 0, 1, 2, point 2, okay, let's say 1 to base 3. So we are converting these two. So converting from any other base to base 10 is that we multiply each of the digits by the place value. Okay, so here is 1, here is, okay, here is 0, here is 1, there's 2, 3, 4, 5. So the place value for here is 1, here is 2, here is 4, here is 8, 16, and 32. Okay, so we take the first digit, which is 1, and multiply by the place value times what? The base is 2 and the place is what? 32, that's to the power 5, plus the next digit 1 times 2 power 4, plus 1 times 2 power 3, plus 0 times 2 power 2, 0 times 2 power 1, and then 1 times 2 power 0. Okay, so here will be 32 plus 16 plus 8 plus 0 plus 0 plus 1, and this will be equal to 57 base 10. Alright, now let's look at the second one. Let's look at the second example with decimals. So for the place value here is 0, 1, 2, then 3. For the decimal part, so it start descending from 3 to 1, 0, then here will be -1, -2, and if they add the numbers, it continues like that. So that is how we convert. First one will be 2 multiplied by 3. I convert it to base 3. The power 3 plus 0 times 3 to the power 2 plus 1 times 3 to the power 1 plus 2 times 3 to the power 0, then plus 1 times 3 to the power -1, and then plus 2 times 3 to the power -2. Okay, so 2 times 3 to the power 3 is 54, plus this will give me 0, plus this will give me 3, plus this will give me 2, then plus 1 times 3 power -1, it will give me 0.33 plus 2 times 3 power -2 is 0.222 recurring. So if I put all this together, if we add them, the whole number part will be 54 plus 3 plus 2, and that will be 59 points. Then the decimal part 0.33 plus 0.22, and that will be 5 base 10. So 2012.12 base 3 is 59.55 base 10. So now you should be able to convert any given base, whether with decimals or without decimals, to base 10, and vice versa. Okay, let's look at some operations on number bases. Let's look at these examples. So let's begin with the first one. 1 plus 0 is 1. 1 plus 0 here too is 1. 1 plus 1 is 2. 2 base 2 is 1, 0. So 111 base 2 plus 100 base 2 is equal to 1011 base 2. Easy, right? Let's look at the second example. So we are performing this addition in base 7. So 5 plus 4 is 9. So 9 base 7 is 1, 2. 7 divide 9 1 times remainder 2. So we'll write the 2 here. Then we'll carry on the 1 here. So 1 plus 3 plus 2 is 6. 6 base 6 is 6. So I'll write down the 6. Then the next digit, 4 plus 3 is 7. 7 base 7 is 1, 0. So 7 divided 7 1 times remainder 0. So we'll get 1062 base 7. Okay, all right. Now let's look at subtraction. Subtraction is quite trickier. So in subtraction, when we borrow, like the normal base that we're working, when we borrow is in tens because it's in base 10. So whatever base you are working, when you borrow is in that number. So we are in base 2. So whenever I borrow any one is 2. Okay, then I'll add it to the next one. All right, so 0 minus 1, I can't subtract it, so I have to borrow from the next digit, and the next digit is 0, so I can't borrow from there too. So I come and borrow from the third one, okay, and then I bring here, I'll get 2. So I can now borrow 1 from here, then here will be left with 1, and then I'll get 2 here, because whenever I borrow is 2. So I'll get 2 minus 1, which is 1. Now 1 is left here, minus 0, which is 1. Now what we borrowed from here is left with 0. So it will be 0 minus 1. The same way I can. So I have to borrow 1 from here. Then it will be 2. Then 2 minus 1 will give me 1. So I'll get 111 base 2. I take it again. Whenever we borrow, and since it's in base 2, it is in bundles of 2. Okay, it's in bundles of 2. So 2, 0 minus 1. Okay, let me clean this. Alright, so 0 minus 1. I can't subtract 1 from 0. So I have to borrow from here, which is 0. So I'll not get to borrow. So I have to continue to the next digit and borrow 1 from here. If I borrow 1 bundle from here and bring it here and untie it, I'll get 2, from which I can now borrow from. So if I borrow 1 again from here, now here will be left with what? 1. And if I bring it here, I'll get 2. Now I can now subtract 1 from 2 to give me 1. Now here is left with 1. So 1 minus 0 is 1. Now this 1 is what I've borrowed to this digit. Now it's left with 0 here. So now 0 minus 1. I can't subtract. So I have to borrow from the next one to come and add to this to get 1. So 1 minus. So I have to come and borrow from the next one. So it's left with 0 here. So I can't subtract 1 from 0. So I have to borrow 1 from here. If I borrow 1 and bring here, I'll get 2. So now 2 minus 1 will give me 1. Then here is 0. Okay. Alright, so let's look at the next one. So this one is in base 5, meaning whenever I borrow, it's 5 bundles. Okay, so 1 minus 2, that one too, I need to borrow. So the next digit is 0, so I can't get to borrow from there. So I can borrow 1 from here, then here will be left with 1. If I bring it here, it will be 5. Okay, it will be 5. Then I can now borrow 1 from here which will be left with 4 here, and it will be 5 here. So if I add it to this, I'll get 6 minus 2 is 4. Now here is left with 4 minus 3, 1. Now here is left with what? 1 minus 0 is 1. Then here is 4 minus 1 is 3 in base 5. Very easy. Okay. So whenever you borrow, it's in the base. Don't forget it's not in base 10. We are not working in base 10. So don't take it to mean it's 10 when you add to this. Okay. So whenever you borrow, if I'm working in base 2 and I borrow, it's in 2 bundles. If it's base 6, it's in 6 bundles. If it's 7, it's in 7 bundles. Alright. Now let's look at the last operation, multiplication. Okay. So let's try multiply this number. 11011 base 2. This time we are multiplying it by 111 base 2 and 1202 base 3 multiplied by 122 base 3. Alright, so let's take the first one. 1 times 1 is 1. 1 times 1 is 1. 1 times 0 is 0. 1 times 1 is 1. 1 times 1 is 1. Then this one to give me 1 times 1 is 1. 1 times 1 is 1. 1 times 0 is 0. 1 times 1 is 1. Then 1 times 1 is 1. Then the last one, 1 times 1 is 1. 1 times 1, 1. 1 times 0, 0. 1 times 1, 1. 1 times 1, 1. Then we'll add this one. So 1 plus 0, 0, 0 is 1. 1 plus 1 is 2. 2 base 2 is 1, 0. So I'll write 0. Then I'll carry the 1 here. 1 plus 1 plus 1 is 3. 3 base 2 is 1, 1. So I write 1. Then carry 1 here. Then 1 plus 1 plus 0 plus 1 is also 3. So 3 base 3 is 1, 1. So I write 1 and carry again the 1. Now get 1 plus 1 plus 1, 3 again. So that'll give me 1, 1. So I write down 1, then I carry on the 3. Then I'll get 1 plus 1 plus 1, which is also 3. So which is 1, 1 base 2. So I write 1, then I'll carry 1. Then 1 plus 1 is 2. 2 base 2 is what? 1, 0, all in base 2. Okay, so the next one, 2 times 2 is 4. 4 base 3 is 1, 1. So I write 1, then I'll carry 1. 2 times 0 is 0, plus 1 is 1. 2 times 2 is 4. Again, it's 1, 1. So I'll write down 1 and carry 1. Then 2 times 1 is 2, plus 1 is 3. 3 base 3 is 1, 0. Then the next digit, 2 times 2 is 4. 4 base 3 is 1, 1. So I write 1 and I'll carry 1. 2 times 0 is 0, plus 1 is 1. 2 times 2 is 4. Base 3, 1, 1. So I write 1. I'll carry 1. Then 2 times 2 is 2 times 1, is 2, plus 1 is 3. 3 base 3 is 1, 0. Then the last digit, 1 times 2 is 2. 1 times 0 is 0. 1 times 2 again is 2. Then 1 times 1 is 1. Then we'll add them. Bring this one down. 1 plus 1 is 2. Then write the 2 down. 1 plus 1 plus 2 is 4. This 3 is 1, 1. So I write 1, and I'll carry 1 over. So 1 plus 1 will give me 2. Then 1 plus 0 plus 2 will give me 3. So 3 base 3 is 1, 0. So I write down 0, then I carry the 1. 1 plus 1 plus 1 is 3. Again, 3 base 3 is 1, 0. So I'll get this in base 3. Get 1, 0, 0, 2, 1, 2, 1, base 3. Okay. Alright. So now let's look at number bases involved with equations. Okay. So if take our first example, if 3 to base x is equal to 20 base 10, we have to find the base of it. We have to find the base of 3 2. So we find the value of what x. Alright. So this is to a base that we don't know. So you know how to convert a given base to base 10. So okay, this is to 0, this is to the 1. So I get 3 times x to the power 1 plus 2 times x to the power 0 will be equal to 20. But this one is already in base 10. So x to the power 1 is x times 3 will give me 3x plus x to the power 0 is 1 times 2 is 2 will be equal to 20. So now it's now to a simple equation. So 3x will be equal to 20 minus 2. So I'll get 3x to be equal to 18. So if I divide both sides by 3, I'll get my x to be equal to 6. So therefore, this is 3 to base 6 is equal to what? The 20 base 10. Okay, let's look at another example. Alright, so if 5 7 base 8 is equal to 2 3 3 base x, we have to find the value of what? X. Alright, so the same way we change this one to base 10. And this one too is not in base 10, so we change that one to base 10. So this one will be 0 1. So 5 multiplying 8 to the power 1 plus 7 multiplying 8 to the power 0, and this will be equal to then 2 multiplying x to the power, this is 0 1 2 to the power 2 plus 3 multiplying x to the power 1 plus 3 multiplying x to the power plus 3 multiplying x to the power 0. Alright, so 8 to the power 1 is 8 times this 5 is 40, and 8 to the power 0 is 1 times 7 is 7, and this will be equal to x to the power 2 is x squared times 2 give me 2x squared plus x to the power 1 is x times 3 will give me 3x, and the x to the power 0 is 1 times 3 will give me 3. Alright, so I can see that this is like a quadratic equation. So 2x squared plus 3x. Now if I add this to this, I'll get 7 and bring everything to the right hand side. It will give me minus 47 plus 3 equals 0. So I get 2x squared plus 3x minus 44 equals 0. So 2 factors of the constant that adds up to give me 3x. So if I multiply this by this, I'll get 88. So in this case, minus 88. And I'm looking for the 2 factors which adds up to give me 3. Then I can see 11 and 8. 11 and 8. So minus 8 and 11. Minus 8 and 11 will add up to give me 3x. So 2x squared plus 11x minus 8x minus 44 equals 0. Alright, then I will now factorize x, then I'll leave 2x, then plus 11. The common factor here is 4, so I'll get 2x, then plus 11 equals 0. So I'll get x minus 4, then 2x plus 11 equals 0. So my x is equal to 4 or minus 11 over 2. But in this question, you can't have a base in minus. So definitely this is out. Our answer is 4 because I can't have a number base to a minus or a fraction or a decimal. So I conclude by saying therefore S is equal to 4. Alright. Now let's look at the last example. In the equation below, solve for x if all the numbers are binary. 1, 1, that means base 2 over x is equal to 100 base 2 over x plus 101 base 2. So it's binary. All the numbers are in binary. Alright. This is very simple. So convert these numbers, these 3 numbers to base 2. First is 1, 1 base 2. 1, 1 base 2 is what? 1 times 2 power 1 plus 1 times 2 power 0. And this will give me 2 times 1 is 2 plus 1 is 3 is 10. Okay. Then the next one is 1000 base 2. And then this will give me 1 times, this is 0, 1, 2, 3. So 2 power 3 plus, all this will give me 0. So 2 power 3 is 8 times this will give me 8. So this one is 8. And then the next number is 101 base 2. And this one too, 012. So 1 times 2 power 2 plus 0 times 2 power 1 plus 1 times 2 power 0. So this will give me 4 times this is 4, then this is 0 and 1. So 4 plus 1 will give me 5. Alright, so let me rewrite this in base 10. So I get 3 over x will be equal to 8 over x plus 5. Alright, so in solving equations like this, I'll just cross multiply. So I'll get 3 multiplying x plus 5 will be equal to 8x. So I'll get 3x plus 15 to be equal to 8x. Okay, then I'll get 15 will be equal to 8x minus 3x. So 15 will be equal to 8 minus 3, 8x minus 3x is 5x. If I divide both sides by 5, I'll get x to be equal to 3. Alright, so our x is 3. This is not the end. Leaving your answer in base 2. So we convert this 3 to base 2. You remember how we convert base 10 to any other base? We'll keep dividing the number by the base. So this 3, I'll divide it by 2. 2 into 3 is 1, remainder 1. Then 2 into 1 is 0, remainder 1. So I'll write it from bottom up. So I'll get it to be, therefore our x is equal to 1 base 2. Alright, so that brings us to the end of the tutorial. If you find this video useful, please consider subscribing and hit the notification button so that you'll be notified the next time I upload a new video. Thanks for watching.